So, in this particular lecture, we are going to continue from what we discussed in the previous part on cloud computing for IIoT. So, if you recall that in the previous lecture, we talked about the different examples of cloud computing platforms for use in IIoT scenarios, and also the usefulness of the use of cloud computing, what it is and what is its usefulness in the context of industrial automation, IIoT and so on. So, we are going to continue further in this particular lecture, and we are going to look at few other examples of use of cloud and analytics, cloud based analytics in fact for IIoT. So, in the previous lecture we talked about the companies like General Electric, Siemens and Honeywell. These are the different industrial service providers, and their different solutions like Predix, MindSphere and the Honeywell's solution we discussed in the last lecture. And there are many others. There are many other companies which have come up with their cloud based platforms for industrial IoT solutions. But there are different other software development firms who have also come up with their IoT solutions, and particularly cloud based IoT solutions and their integration with analytics, right. So, examples of this would be the C3 IoT, Uptake and the Merciful. So, these are a few of the other examples of the use of cloud based analytics for IoT, and these have been developed by independent software development firms. So, we will take up each of these, and we will just quickly we will glance through some of their highlights or the features that they have. So, C3 IoT basically offers some kind of a platform that can help in different analytics and prediction, and it is cloud based. So, it is cloud based services and including analytics, prediction and so on, and this particular platform is secured, and there are authentication mechanisms, appropriate authentication mechanisms, authorization mechanisms etc., which have been implemented. And these analytics that I was talking about in C3, these are basically AI based, machine learning based analytics. Different tools have been provided catering to the different requirements in the industrial setting, and these data based on which the analytics are done are stored in something called the C3 data lake, which basically stores all these unstructured data that are typical of IIoT in using some kind of a format which is known as the RESTful architecture format. So, this is how all these data are stored. So, the data are stored in the data lake, all these are unstructured data, these are stored in the data lake, plus there are different powerful AI based analytics, prediction and so on, and everything together is a secured platform, and the security is offered in the form of authentication, appropriate levels of authentication, authorization and so on. So, C3 IoT platform tools have different components such as the data integrator, IDE, data explorer, analytics designer, X Machina, data science notebook, type designer and so on. I am just naming these. Unless you are interested to know each of these tools, I think this is sufficient just to get an overall idea of what each of these tools do and what are their different components. So, that is why I do not get into the details of each of these components of these vendor specific tools. So, the other things are the different other tools like the SaaS tools for IIoT specifically, performing things such as predictive maintenance, inventory optimization, supply network, energy management, fraud detection, sensor health monitoring and so on. So, these are the two classes of tools that have been provided in C3. Uptake is another solution which is an analytics solution for catering to enterprise requirements, and Uptake basically gives high valued services at a low cost. That is their motive, their objective, which is basically to offer high valued solutions at low cost and identifying the strength and goals of business through trade discussions. This is what Uptake does. So, as we can see that uptake overall is talking about offering advanced analytics catering to the requirements of the business or the enterprise, and it is cloud based and targeting the specific industry based requirements that are there. So, this is the overall architectural view of uptake. So, there are different layers. One layer basically talks about the customer satisfaction. The bottom layer basically talks about the customer satisfaction, which caters to requirements of securing the services, offering smarter storage, complying with legal issues, regulations and so on. The second tier offers technological support, talking about taking care of revenue flow for the subscribed user services, automation, technological advancement, ease of buying and selling and so on. And the third tier basically talks about improved resource utilization, avoiding replications, growth in production, effective cost computation. These are the different properties of this particular layer. So, that was uptake. The third one is Merciful. Merciful is an IIoT platform that helps in faster development, faster deployment of the processes, helps in real time monitoring of all kinds of machinery, processes, different instruments, etc. The solutions that they talk about are of low cost, and there are different components over here of Merciful. One component is this now, the second component is the tracker, and the third one is the enterprise. So, let us look at a very high level what each of these components do and how they position themselves with respect to each other. So, let us assume that this is our Merciful. This Merciful has these different components now is one, which takes care of issues such as asset tracking in real time, because that is what is important for IIoT, asset tracking in real time. Then this enterprise talks about full stack IoT solutions, flexible configuration support, custom notification facilities and so on. And the third one is this tracker, which talks about which takes care of faster deployment, real time monitoring and visualization. These are the three main components of this platform Merciful, which has been developed for IIoT requirements. Now, let us come to this cloud, which is the focus over here of this particular lecture. Cloud is very important. Cloud helps in doing number of different things. So, cloud basically will help in doing number one, device management. Now, what is this device management? Device management basically talks about managing the devices. So, let us now look at why this device management is important. So, we have this device management, and why this device management is required? There are number of reasons why it is required. There may be faulty devices, there may be change in standards that might happen from time to time. There may be a need for catering to some requirements in a timely manner. Device management is also required for several other reasons. For example, taking care of large or rather huge number of devices together, which is typical of industrial IoT solutions. And also last but not the least over here that I can think of is this security. So, security offering, so whatever the device management that we do, securing the overall the devices and the platform is the most important thing. So, catering to all of these is what is required, and that is where device management is helpful. So, for this device management, cloud based solutions are going to be useful. So, why do we need cloud based solutions? Cloud based solutions will help us in doing a number of different things. So, why cloud based? Why cloud based? Why cloud based device management? Cloud based device management has different features. Number one is it is going to help in efficient provisioning and authentication, efficient way of doing it, authentication. Cloud based device management will help in efficient fault diagnostics, because if it is cloud based, then we are going to run the analytics in a much more efficient manner, right, and that can be done in the cloud. So, cloud will give us ample processing, whatever is required, processing power plus storage, etc. So, running this real time analytics, etc. for fault diagnostics, etc. are going to be much more doable if it is cloud based. So, cloud based device management for fault diagnostics. Number 3 is efficient way of carrying out updations and maintenance. Number 4 would be the issue of efficient way of configuration and control. Number 5 would be if it is required, sometimes it is required to remove a particular device, to add a device, to change a device, to remove a device and so on. So, that will be also facilitated. So, removal or rather changing a device much more efficiently can be done with the help of this cloud based device management, IIoT device management. So, there are different companies which have come up with their solutions. Companies such as Robert Bosch, they have their solutions. Companies such as Amazon, they have their AWS and also the specific solutions catering to IIoT requirements. Then we have ICP, then Verismake and so on. So, these are the companies, these are some of the companies. Like this there are many other companies which do cloud based, which offer cloud based solutions for device management, right, offer cloud based solutions for device management. Now, let us go back to what we were discussing earlier. So, we have understood that device management is very important, because we are talking about in IIoT scenarios large number of devices, taking care of large number of devices in a typical IIoT deployment scenario. and you have to take care of different requirements, starting from their configuration, provisioning, faults, security, and so on and so forth. So, the ecosystem overall is highly complex and you need some kind of a solution. The solution, if it is cloud based, we have seen that what are the advantages of doing it, and overall cloud based device management solutions are going to be helpful to offer different attractive services to the clients. So, these are the needs for device management we have already seen, and their different functionalities and why it is required to have this cloud based device management solution. So, these are some of these features that cloud platform service providers should offer for device management: provisioning and authentication, which we have seen already, fault diagnostics and monitoring, updates, security patches, maintenance, device decommissioning, commissioning, configuration, control. These are different things that cloud based device management solutions will offer. These are some of these companies that I mentioned: Bosch's IoT Remote Manager, Amazon's IoT Device Management for AWS, Verismic's Cloud Management Suite, ICP's IoT Star, Software Edge's Cumulosity, and so on. Like this, there are many different other cloud based device management solutions out there. The next thing is that service level agreement. So, service level agreements or SLAs are very important, particularly when you are talking about cloud. So, SLA is service level agreement between whom? Between the provider about what services are going to be provided and the consumers of the service. So, cloud service provider and the cloud service consumer, who are basically these companies which are using these different services, the IIoT solutions which are cloud based and so on. So, there are many IIoT applications that are real time, where safety is very important. So, you need to have some kind of SLAs which will cater to the specific requirements that are there, and these services should be offered as per the agreement with the cloud provider, right. So, it is some kind of a promise of delivering something through some formal agreement which is often legal in nature. So, SLAs basically help the industrial clients to check what and how the cloud provider gives as services. So, how good these services are, this is what this SLA and the measurement of these which is important. So, SLAs have different features. SLAs can be very simple, naive and so on, but meaningful SLAs will have certain good characteristics, which are desirable. So, these are some of these different characteristics that you see in front of you. A good SLA should be achievable, something that can be achieved, not something that is a dream and so on, which cannot be done within the required span of time and so on. Second is that the good SLAs should be meaningful, right. It should not be vague, it should be precise, meaningful, quantifiable, because only if it is quantifiable then it can be measured and you can enforce certain requirements and legalities etc. based on these different measurable quantities. Fourth is that a good SLA should be controllable. Fifth is that it should be mutually acceptable, which is also quite well easily understood, and should be affordable. So, these are the 6 different characteristics of a good SLA when we are talking about cloud, particularly in an industrial setting, IIoT based setting. So, let us now again take a look and take a recap of what we have discussed. So, let us say that we have this IIoT solution. So, we have this IIoT cloud service provider, right. So, this cloud provider is going to sign up an SLA with the industrial client. With the industrial client. So, this SLA basically, as we have seen, will have different goals, time plan, list of deliverables and the specificity about the budget. So, this is what should be done in a cloud based IIoT solution that is offered to the industrial clients. So, SLAs should be there catering to these different requirements and the features. So, let us go ahead and look further. So, the current status and future of SLAs in IIoT. So, SLA compliant cloud service in IIoT is still in an infant stage, because IIoT itself is in its infancy. Although there are bits and pieces that are already implemented, particularly from an automation point of view, but cloud based this kind of solution, particularly SLA compliant, you will find that it is not much matured yet in most of the cases. So, quality of services offered at this point has lot of interdependencies, that is why it is still in its infant stages. The methodologies and frameworks of IIoT are not well developed. Life cycle management of an SLA in the industrial context is not clear, and the lack of SLA enforcement policies for both the consumers and the providers is also quite evident at present. So, there is lack of SLA enforcement policies. So, SLA support for IIoTs is crucial, particularly from a business model point of view. So, whenever we are talking in the future of IIoT standardization of SLAs etc., we have to take all these different lacunae into account and try to address them in the future, so that it becomes a very important necessity in the business negotiation process. So, it is required to choose the right cloud vendor for IIoT. There are different cloud based IIoT cloud based solution providers that are already there. So, it is very important to look for the correct vendor that will cater to the specific requirements that a particular industry has. So, a checklist will help in basically trying to identify the right cloud vendor for IIoT. So, this checklist is given over here, taking into consideration points such as scalability support, whether the particular cloud vendor that you want to choose has support for scalability. That means, if you have dynamically, if your requirements increase and so on in terms of these different computational resources etc., whether the cloud vendor would be able to support that, number one. Number two is the bandwidth requirement, which is well understood. The communication protocols that are supported, whether it is MQTT, AMQP, HTTP or the other protocols that are there. So, which ones are supported? MQTT is more common, but then AMQP is also coming and so on. So, which ones are there that are supported by the cloud vendor, and which of these protocols are going to help you cater to your specific requirements that you have for the IIoT solution that you want to deploy or is already deployed. Security, I do not need to elaborate further. Interoperability also the same. Edge intelligence feature is very important. So, edge intelligence. So, whether this particular cloud based solution offers certain edge intelligence, that means that wherever close to the point of collection of data, that means the machines which have these IoT devices installed to them, whether all these data are sent to a remote cloud which will take a lot of time etc. to send the data and also to process and give back the results and so on, or some of the analytics can be done at the edge, that means at the local gateway or hub or whatever. So, that will make the life faster, but at the same time not everything can be processed at the edge. So, ultimately some of it will have to be done remotely at the cloud. So, edge intelligence features, infrastructure management. These are some of these different parameters that can be taken into consideration for choosing the right cloud vendor for IIoT. So, limitations in the cloud based approach is that we are talking about a scenario. In the case of IIoT, we are talking about scenarios of machines, large number of machines equipped with large number of IoT devices and so on, sensors, actuators and so on and so forth, and supplying large volumes of data coming at huge velocities, having high variety, big data, basically essentially big data characteristics are there, and whether your cloud based solutions will be able to cater to the requirements or not, these kind of requirements. So, if you are sending everything to the cloud, obviously taking care of issues of volume is fine, but velocity, particularly real time processing, faster processing, etc., that may be difficult, because there is going to be higher latency. You want to send everything to the cloud, you want to send everything to the cloud at the back end, which is maybe the server where it will get processed is located continents away. So, this is going to in turn impact the overall latency. Propagation delay is going to increase of the packet that is sent from the device in the machine to that cloud, and also processing it over there and then getting it back again the results to the user end, that again will add to the time. So, higher latency is going to be there if everything is cloud based. Bandwidth requirements for huge data volume will be there, because you are talking about huge volume, high velocity, volume, variety and so on, all these big data characteristics. So, you need the channel also to be of a high capacity, high bandwidth. There is a requirement for the big network and need for scalable security. These are some of these limitations in cloud based IIoT solutions. That is why there are these different other solutions people are thinking of. So, entirely centralized cloud based solutions are the ones that we talked about, and they suffer from many limitations which we have already seen. Now, people are talking about decentralized approach that will decrease some of the load on the cloud and will also make our lives faster by processing certain things at the edge. So, it is sort of like cloud, partial cloud at the edge, that means closer to the devices from where these data are generated. And real time operations feasibility, greater mobility support, these are some of these cloud based centralized approaches and how they suffer from these different these different ailments and the different other characteristics, the desirable characteristics, mobility support, operations, real time operations feasibility, those are required and so on. So, if we are talking about industry 4.0, take a look at what we discussed earlier several lectures back. We talked about industry 4.0 having objectives of offering robust solutions, higher production, improved customer satisfaction, expanded security, improved performance and so on and so forth. These are some of these different industry 4.0 objectives. So, from a IIoT viewpoint, these requirements will aim to achieve greater production, optimized decisions will be possible with higher efficiency and availability. It is also possible to have deeper insights of analysis and prediction, establishing a connected world of machines, systems, products, environments with the help of IIoT, connected IoT, connected machinery, connected IoT devices on these machineries and so on, and the collection of data from each sector and performing analytics to exploit the wealth of its benefits. These are some of the requirements from IIoT perspective. So, the solution is to have some kind of a decentralized or distributed approach along with the centralized cloud, which will help in handling some time sensitive data, where immediate actions will have to be taken, some quicker responses will have to be taken, and some processing will have to be done faster instead of sending everything at the cloud, which will overall increase the latency. So, that promptness in the processing, at least to some level, That can be done with something, a newer solution that is coming up, which is the fog. So, fog is an emerging technology which will help to perform some of this processing closer to the point of origination of the data, and the rest of the processing can be done at the cloud. So, fog computing basically offers an added layer between the edge layer and the cloud layer. However, keep in mind that fog cannot do everything, it cannot solve all your problems. It is not that fog layer can do all the processing that would be otherwise done at the cloud. So, only some meaningful processing of some raw data before it is actually sent to the cloud, and also some processing that has to be done quite fast will be done at the fog. So, intelligent devices are deployed at the edge. Intelligent computing devices such as the fog nodes, which are known as the fog nodes, would be deployed, which can offer different services such as filtering of the data, aggregation of the data, translation of the data, and so on. So, with this we come to an end of the lecture on cloud computing for IIoT. Holistically, previous lecture and this lecture onwards, this lecture included, we have seen the different features of cloud. We have looked at the requirements of cloud, why cloud based solutions are required, why cloud based analytics solutions are required and how they are useful, and how this cloud based solution is going to help in catering to certain real life industry 4.0 IIoT requirements that are there in the industries. We have also looked at certain specific solutions that are there, some industry specific solutions, some software independent software company based solutions and so on, and how they can help in addressing some of our requirements. So, with this we come to an end, and these are some of these different references that are there, and if you are interested you could go through these different references. I would suggest that you go through this particular paper that was authored by me. So, assessment of the suitability of fog computing in the context of Internet of Things, which was published in the IEEE Transactions on Cloud Computing in 2018, and so the other papers and this one together will help you to get an understanding of two technologies. One is cloud for IIoT, and also the newer upcoming technology fog, which I am going to again discuss in further depth in the next lecture. So, fog and cloud together, all these references will help you to get a deeper insight, and what is required to have is some kind of suitable cloud fog based solutions for catering to the IIoT requirements. With this we come to an end of this particular lecture. These are these other references that are there, and thank you.